the discharge rating curve and by using Microsoft Excel. Taking an examples from a text like that, such questions, the discharge stage data of river are given below, and stage establish the stage discharge relation to predict the discharge for a given stage, and assume the value of stage for a zero discharge as 35 meter to what is the correlation coefficient of the relation established above, and estimates the discharge corresponding to the stage value of 42.5 meter and 48.5 meter respectively. In the third equation, how to extend the rating curve after established by using some known zero discharge stage stages for zero discharge. So in order to determine the stage discharge, should be follow the following steps and use the following formula. For in this given equation, the stage for zero discharge is equal to 35 meter, and this 35 meter, and also the discharge equation for stage discharge relationship or power type curve fitting meters can be expressed by using this formula. Q is equal to CR open bracket G minus A the power of P. CR and beta, it is a constant, that means it is rating curve constant that determined by using simple square rating curve method, and G means it is the gauge height at a given time or at a right time, and is a constant with respect to the gauge reading corresponding to zero discharge. Simply, it is a stage for zero discharge. And first determine the rate curve constant CR and beta as follows by using Excel. So in order to determine these two constants, you should be follow or should be convert the above equation, that means Q is equal to CR into G minus A the power of beta in a logarithm form in order to for least square error meters. Log Q is equal to beta log G minus A plus log CR. So by using a logarithm property, log CR G minus A is the power of beta is equal to beta log G minus A plus log CR, and denote log Q is equal to Y and log G minus A is equal to X, and also log CR is equal to beta. It is Y is the dependent variable, and X is the independent variable, and also beta is equal to log CR, it is a constant, or in a sense it is Y is equal to bx plus beta, means beta is a slope for a linear equation Y is equal to beta x, and B is the Y intercept. So to first determine beta and B. So the equation that is used to determine these two parameters, first one is beta is equal to n a summation of xy, summation of the product of xy minus epsilon, or the summation of x times the summation of y, over n the summation of x square minus the summation of x the whole square. By using this formula, we can determine the power of the rating curve constant beta, and B is equal to summation of y minus beta times the summation of x over the total n, or n means it is a number of samples, or a number of records. So after determining beta and B, after determining B, we can determine CR, because CR means it is the anti-logarithm of B. So in order to determine how much this stage and discharge can be correlated, So to determine the correlation between these two variables, we can use R, or coefficient, correlation coefficient, moment correlation coefficient. These R can be determined by using this formula. If the R value is approached to 1, there is a good correlation between Q and stage. If there is or the value of R it is approached to 0, the correlation between the two variables are less, or it is poor. So it should be adjust the zero gauge heights until we get the until you get good correlation r value can alterate the value of a small a. That means it is the gauge height for a zero discharge. So in order to determine, or in order to simplify our calculation, we can use a Microsoft Excel. So then step to open Microsoft Excel. So this is a Microsoft Excel. So in this, after opening this Microsoft Excel, should be adjust the data in suitable manners. For example, it is can adjust like that. It is stage in meter, and also discharge in meter cubed per second. So after adjusting this, should be write the value in each in corresponding columns, like that of 35.91, 36.9, 37.92, sorry, so 89, 230, 360. So okay, save. After adjusting this data, it should be subtract the zero discharge, or it is denoted by a. Okay, a, and it is also denoted by a. So we can subtract the value of a from each stage height. It is J, capital J. It is log capital J. So this, from this column, we can subtract the value of A. That means this value is equal to the each value of the gauge height recorded at a specific period of time minus the zero discharge gauge. So by using this formula, we can determine G minus A. After determining G minus A, we can calculate, or we can add a logarithm. So it is y is equal to log Q. Sorry, it is not this. It is, we can proceed x is equal to log or open bracket minus a, small a, and also y is equal to log Q. So we can it is G minus A, and we can find a logarithm value by using this is equal to log Q and double click. We can use this or this value, and we can double click and enter this value, and also drag this value, and can get this column by using log common logarithm, sorry, common logarithm, and also calculate the value of y by using log is equal to this value, and can get y value. After calculating this value, we can adjust rating are constants. So from this equation beta can be determined by using this formula, then n is summation of xy cn, or we can take this formula or can translate this formula into move this formula into Excel in order to use in order to simplify our works. So it is based. So from this there is n value, or it is a number of samples. This is equal to sum no sum sorry this count count of this value, and enter. There is 30, n is equal to 13. So n can be calculated, then beta is equal to where is beta? Yeah, we can denote beta, or in order to get the beta we can just enter and symbol, and you can get beta value. Yes, it is beta. Say enters, it's close. So there is beta, and after calculating beta there is b value, small b value, and also cr is coefficient of correlation. So in order to determine these variables, you should determine the summation of the product of xy and the summation of xy, summation of y, and the product of, or the summation of x square, and the square of sum of x. Then you can calculate it is xy. Yes. So x square, first calculate x square, or xy, simply xy, and xy, x square, yes, x square. So first calculate this parameter. If there is left some parameters that required, can calculate. From this there is y square, yes, y square, simply just cell format. Oh, sorry. Yes. Superscript. Okay. In this case, we can just this value. That's also superscript. Yes. This is a value, and just we can calculate xy. It is equal to, it is simply the product of x and y. It is times x value, and we can drag this value. Yes. Y is x square is equal to x times x1. So, and drag, and y value, y square is equal to, it is y square equal to times y. Okay, drag it. Yes, this is a parameter that, or sorry, it can not parameter, or can say parameter, in for a sake of simplicity our work we can say xy, x square, and y square can say parameter. You can say a parameter in order to simplify our works, or in order to simplify our understanding. So after calculating this value, we can determine a summation of xy, summation of x, summation of y, and summation of xy square. So sum of this value, sum of this value, sum of this value, yes. Oh yeah, sum of this value, sum of this value, sum of this value, and sum of this value. Then it is sum, Canada, it is sum, and it is equal to sum. Okay, double click and just drag, simply enter, and from this there is equal to end sum, enter, yes. It is sum, yes. It is a product. Oh no, adjust this value and we can it is sum, you can end automatically sum, and but can write this value, double click, yes, and it is also product. Oh, and also we can drag, yes. It is sum, yeah, it's good. It is sum, yes, it is good. And also it is sum of this column, yes. After calculating this value, we can determine, or we can use this formula in order to determine beta. So beta is equal to n times, it is n value, n times bracket summation of xy. Summation of xy, it is this value, yes. Summation of xy it is value minus the summation of xy times the summation of xy. So open bracket and okay, summation of x means it is value times, and summation of y is this value, okay, over bracket n times, it is n is 13 times, okay, and summation of x square. There is x square and there is their summation. Then we can summation of x square means this value, yes, and minus summation of sum of x square, yes. There is x and the power of 2, and this is a formula. If there is error of a bracket, we can adjust, yes. This is beta value, yeah. It is a beta value, it is beta value, okay. It is a beta value. If there is some error, we can adjust, uh, it is beta value, okay, can check the value, check, okay. In this c3 means this value, yes, n times summation x square, yeah, x square, okay, minus f minus f3 summation of x, that means this value whole square, okay. And after this determining this value, we can determine beta, b is equal to a summation of y. There is summation of y, this value, minus beta times summation of x. It is beta times summation of x. What is summation of x? This value over what? Can use a bracket, and over this value. It is beta, and c is equal to the anti-logarithm of this value. Then it is equal to 10 the power of this value. Oh, it is not good. I think there is a mistake. Can I just, oh sorry, this value, cannot adjust. Okay, we can use this value and we can adjust. Yes. Oh, what? Yes, there is. Yeah, it is good. So from this, there is n value is equal to 13 and beta is equal to 1.6959 and b is equal to 1.85 and also 70.84. There is the relationship between from our question. We can enter the question. The first question establishes the state discharge relationship to predict the discharge for a given stage. This relationship is equal to this relationship is equal to q. Q is equal to c means cr from Excel, or we can copy this value. In Word. In this Word. Okay, copy. Oh, sorry. Paste. Okay. Yes, this value. Then okay. Q is equal to cr times into j log j minus a minus e, the power of beta. But then the equation or q can be expressed by using this formula. Q is equal to q is equal to 70.84 times bracket g minus where is a 35, yeah, 35, the power of 1.6959. This is the established stage discharge rating curve. Okay, it is established discharge rating curve. So this is the value that is to express the relationship between stage and discharge. So by using this relationship, we can determine or we can predict any discharge at a corresponding a given gauge. For example, from in our question, what is the correlation coefficient of relation established? Then determine the correlation coefficient are equal to by using this formula. Okay, we can calculate the numerator and the denominator. It is numerator, then numerator is n times xy minus x3, and it is equal to n means 13 times n is times and xy, summation of xy means this value minus summation of xy times summation of xy, no, this value times this value, the yes, or can use bracket, sometimes bracket. Okay, and the denominator is equal to square root equal to square root of n times what? N times x square, summation of x square, okay, minus sum of x square. Ooh, sum of x square, okay, times bracket n times summation of x square, y square, sorry, y square minus summation of y square. Enter. Okay, okay, no, 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 okay, okay, this bracket is okay, can use this bracket, another bracket inside, yeah, yes, then r is equal to this value over this value. Yes, it is good. Yeah, it is, r it is more approaches to 1. So this value, it is good relationship between, it is a correlation factor. It is correlation, the correlation of the stage and discharge. There is good correlation, very good correlation. There is good correlation. Yes, there's correlation. So it is the correlation, yeah, the correlation value, it is r is equal to 0.983. Then we can go in this Microsoft Word, question to correlation, the correlation of the stage and discharge is good because r is equal to 0.983. It is near to 1, yeah, it is near to 1. There is a good correlation. It is, we can, sorry, please, no, yeah, it is value. So third one is, it is question 1, it is answers for question 2, and the third one is estimate the discharge, at G is equal to, I think you can see from the equation, 42.5 and 48.5. 42.5 and 48.5. Okay. This point we can determine the gauge by using this relationship. So let us go to in Excel. Determine G is equal to 42.5, then capital Q, how much? By using this formula, it is equal to then 70.84 times bracket G means this value minus 35 yeah, the power of 1.6959, enter. So yes, this value is the value of q at a gauge height of 42.5, and for g is equal to, or g2 is equal to 48.5. It is can drag, can drag it. Yes, it is a value. So at this height the value of q is equal to this one. This one. Thank you everybody. To like this video, you can share, subscribe, and like this video.